With alternating current, the current in, say, wire 1 is constantly changing in magnitude and direction. So here we have a coil of wire, and we have a changing current. We can think of the charges as shuffling first this way, then that way, then this way again, then that way again, then this, then that, then this, then that, back and forth constantly. This causes the magnetic field around wire 1 to constantly change. Recall that a magnetic field is set up anytime you have charges in motion. And if the charges are moving one way, then the magnetic field has a certain orientation. If the charges then shuffle back the other way, the direction and magnitude potentially of the magnetic field change. So, when you have a changing current, you necessarily get a changing magnetic field. Now, if we have a second loop of wire that's separate and closed, when that loop that's nearby the first loop, when it senses wire 1's changing magnetic field, it induces a current in that second wire. So when wire number 2, when coil number 2 is nearby coil number 1, and coil number 2 senses the changing magnetic field from wire 1, it sets up a current in wire number 2. The induced current in wire 2 then generates its own magnetic field, which opposes the magnetic field from wire number 1. So what we have are two magnetic fields that are opposing each other. This last statement is called Lenz's law. Lenz's law is a consequence of the law of energy conservation. If the changing magnetic field around an AC conductor induced an AC current in a nearby conductor, which then produced a magnetic field additive to the first one, that would be like getting something for nothing.